Isaac Newton's work in alchemy is a fascinating and often overlooked part of his scientific legacy. Although Newton is remembered for physics, calculus, and optics, he actually spent more time on alchemy and theology than on what we now call science. Newton put together one of the finest libraries of alchemical literature ever assembled, and he wrote more than 1 million words on alchemy in his own laboratory notebooks. Most of all, he spent untold hours hunched over bubbling retorts of mercury, lead, antimony, and sulfur, a practice that may have damaged his health. His notebooks weren't revealed until the 20th century, when economist John Maynard Keynes bought them and famously said, "Newton was not the first of the age of reason, he was the last of the magicians." In 1936, scholars who studied Isaac Newton were stunned. That year, the auction house Sotheby's released a catalogue listing 329 lots of Newton's manuscripts, most written in his own hand. To everyone's surprise, more than 1/3 of these pages were unmistakably alchemical. These papers had been marked not fit to be printed when Newton died in 1727, and their sudden appearance raised many questions that still intrigue us today. Was the father of modern physics really an alchemist? And if he was, what should we make of that? Did Newton study alchemy for scientific reasons, or was he chasing the age-old dream of turning ordinary metals into gold? Did he believe alchemical texts hid secret religious messages, describing divine knowledge passed down to a select few? Or was he drawn simply to the dramatic, mysterious imagery of alchemy? Pictures of hermaphrodites, dragons, green lions, and other strange symbols. The mystery only deepens when we look at Newton's laboratory notebooks. Even the notebook containing the first complete description of his groundbreaking discovery that white light is made of many distinct colors also includes alchemical recipes borrowed from the same types of sources found in the Sotheby's manuscripts. Alongside careful explanations of freezing, boiling, and optical experiments, we also find references to Neptune's trident, Mercury's caduceus, and the green lion, all traditional alchemical symbols. Whatever Newton hoped to achieve through alchemy, one thing is clear: we cannot neatly separate his alchemical studies from the rest of his scientific work. They were deeply intertwined parts of the same curious, searching mind. Irenaeus Philalethes was one of the most celebrated alchemical writers of the late 1600s. His work deeply influenced major scientific figures of the time, including Robert Boyle, and later became an important source for Isaac Newton's own alchemical studies. Neither Newton nor Boyle ever met Philalethes in person. That's because Philalethes was a pen name. His real identity and work were shared with the world by his friend and fellow American George Starkey, who was also an active chemical experimenter. Though Starkey's own reputation never reached the same heights, he played a central role in spreading Philalethes's writings. Starkey had been well educated by colonial standards. He graduated from Harvard College in 1646, at a time when the school was a leading center of alchemical study in America. In 1650, he sailed to England, partly to advance his career, and partly because high-quality laboratory equipment was scarce in the colonies. Once in England, he quickly attracted the attention of those interested in chemistry, and even served for a time as Robert Boyle's alchemical mentor. Newton and Boyle had a significant connection to alchemy, as both were deeply involved in its practices, with Boyle potentially influencing Newton's work, and both seeking the philosopher's stone. Newton was concerned that Boyle might reveal too much about sophic mercury, a key alchemical ingredient, and attempted to acquire Boyle's alchemical notes after his death. Despite Boyle being known as the father of modern chemistry, his alchemical pursuits were a major, though often suppressed, part of his life and work. Mineral acids were among the chemicals Isaac Newton used most often in his experimental work. or chymistry, as he called it. These included oil of vitriol, sulfuric acid, aqua fortis, nitric acid, and spirit of salt, hydrochloric acid. He also used mixtures of these acids, such as aqua regia, a powerful blend of nitric and hydrochloric acids known for its ability to dissolve gold. The knowledge behind these strong waters didn't start with Newton or even with European alchemists. It can be traced back to early Islamic alchemists like Jabir ibn Hayyan and al-Razi, who, between the 9th and 10th centuries, developed ways to produce concentrated acids by distilling minerals. Their work influenced medieval alchemists and physicians, who continued refining these techniques. Newton was well aware of this tradition. In one of his manuscripts, now held in the Bodleian Library at Oxford, he describes these acids and outlines how to prepare them, showing just how deeply he engaged with the long history of practical chemistry. Newton's search for mercury of life, also called philosophic mercury, mercurius vitae, or the living mercury, was one of the most intense and secretive strands of his alchemical research. These experiments appear throughout his notebooks, especially in the Clavis, Index Chemicus, laboratory notebooks, and his copies of Starkey Philalethe's, but remained highly coded. What was mercury of life? In alchemy, it was believed that all metals were formed from two principles: sulfur, active, fiery principle, and mercury, volatile, formative principle. The mercury of life was imagined as a purified, enhanced form of mercury that could dissolve metals radically, serve as the seed of transmutation, rejuvenate matter, reveal the vegetative power inherent in metals. Newton believed the mercury of life was not ordinary quicksilver, but a special mercury derived from antimony, capable of entering metals and transforming them. Newton's view of matter was strongly shaped by these experiments. Through them, he developed ideas such as active principles, attractive and repulsive forces between particles, transmutation as the rearrangement of particles. These ideas subtly influenced his physics and later chemistry. Newton's alchemical recipes, the green lion eating the sun. This is one of the most famous symbolic recipes Newton copied and annotated. Symbolic instruction: the green lion devours the sun. Newton's interpretation: green lion equals an aggressive solvent, usually aqua regia or antimony chloride. Sun equals gold. What the recipe actually describes is the dissolution of gold in nitrohydrochloric acid. Newton kept notes on proportions of acids, temperature control, and evaporation to red crystals, tincture of gold. This was later relevant to modern gold chemistry. Another recipe was of the dragon and the eagle, sublimation of mercury and antimony. Newton often recorded the symbolic marriage of mercury and metals. Historical recipe, summary: mix mercury, antimony sulfide, and sal ammoniac, ammonium chloride. Heat in a sealed vessel to drive sublimation. Collect white or red sublimates, ammoniated mercury compounds. Modern interpretation: this procedure creates compounds like mercury 2-chloride, HgCl2, and mercury ammonium chloride. Newton believed these were stages in producing philosophic mercury, a key agent in transmutation. Star regulus, crystal formation. Newton was fascinated by the star-shaped crystals that antimony sometimes forms. Antimony metal can form beautiful star-shaped crystals if it is cooled very slowly, while covered by a thick layer of slag. To obtain the metal in the first place, alchemists heated the mineral stibnite, SbB2S3, together with iron and saltpeter until the mixture melted and the antimony separated. The metal that appears at this stage is still impure, so it must be melted and refined several more times, again using saltpeter, before it can develop the distinctive star pattern during slow cooling. The net. This purple-colored alloy made from antimony and copper appears often in Newton's chemical notebooks, along with step-by-step instructions on how to make it. The process begins by extracting metallic antimony from its ore, stibnite, using iron. Once the antimony is purified, copper is added to create the alloy. Newton learned this technique from the alchemist George Starkey, who wrote under the name Irenaeus Philalethes. Starkey called the alloy the net because its surface is covered with tiny, regular crystal patterns that reminded him of a woven mesh. He even connected this material to a story from the Roman poet Ovid, in which the blacksmith god Vulcan traps the lovers Mars and Venus in a finely crafted bronze net. Starkey believed this myth secretly referred to the chemical combination of iron, Mars, and copper, Venus, both of which are used to create the alloy. Newton accepted this symbolic interpretation and explored the alloy accordingly in his own alchemical studies. Finally, today, researchers believe that Newton's alchemical research was not separate from his scientific work. He used alchemical techniques and ideas in his experiments, particularly in his work on optics, where his experiments on white light drew on alchemical concepts. Some modern historians view his alchemical work as crucial to his scientific breakthroughs, seeing him as an alchemist who used experiment and empiricism to achieve scientific knowledge. Newton is seen as a bridge between the mystical traditions of alchemy and the rationalism of the Enlightenment.